Like guys, I heard a lot of you do not understand about single slit diffraction, right? So let's do a quick revision on that. Before we do single slit, let's recap on double slit, diffraction grating. Then we do in-depth on single slit, okay? Now for double slit, you need to recall back all the formulas. You need to compare them and remember them. X equal to lambda d over A for double slit. This formula is only true for first maxima. It is not true for second maxima because the angle of diffraction must be small. What is the angle of diffraction? The angle of diffraction I'm talking about is this angle. Okay, this angle from here to here. That's called the angle of diffraction. All right. Now, D must be much bigger than A. What is D? D is the separation between the screen to the slit. This is the distance D I'm talking about. And this is A. This A is called slit separation. This is the 0th order maxima, first order maxima, second order maxima, but we don't care the second order. We only do up to first order. I just want you to remember this x1 and x2, they are not the same, okay? x1 is smaller, x2 is bigger. This x represents what? X represents from bright to bright fringe. We call it the fringe separation. Now, what about diffraction grating? Diffraction grating, we got many slits, many openings. And let me zoom in. What is small d? Small d is this distance. This distance is called small d. Yeah, it's the same. It's called slit separation as well. But it's much harder to measure, right? So usually in the exam, they will give you d as 1 over p. And p is in lines per meter. If it's lines per millimeter, you need to convert it to lines per meter. Now, so this is very important. And this is true for any orders. This is true for any orders. So for example, let's say this is the first order. Let's say there's a second order. So we say at this point is n equal to 1. At this point, n equal to 2. At this point, n equal to 0. Of course, below also n equal to 1, n equal to 2, etc., etc. So this is for first order angle theta, theta 1. The second order is this. Always remember, it must measure from the 0th order. Now, so what is the difference between this and this? This and this one is very bright and sharp. Why? Because during interference, what happened is that this and this only meet A and A. So the most is 2A. The most is 2A, right? But for this is different. For this, you will have multiple interference possible. So let me erase this first. Okay? So it could be here A. It could be 100A if there's 100 slits, okay? So that means the amplitude is extremely high. Still remember intensity proportional to amplitude square. So when the amplitude is very high, the intensity will be very high. Intensity represents brightness, okay? So in other words, for diffraction grating, the image here will be much brighter and sharper. That is the advantage. And we love to use diffraction grating to measure things because it's easier to measure. Now let's look at single slit. Sin theta is lambda over b. This one only true for first order minima. And now let's focus on this. Now, so this is called the b. It's called the b, the lambda. And what is this theta? Theta is referring to this theta again. Same thing again, but this is first order minima. The fringes will be like this. The fringes will be like this. You get first order minima here. That is the main idea. That's the main difference. So let's focus more on this. Let me draw on another page. Let me draw bigger, okay? All right, this is your lens. This is your retina. Imagine you have an object here. You have an object here. So what happens when this object passing through a slit? Okay, so don't be exactly. Let's say it's here. So what do you see? They will diffract, right? When they diffract, they will become what? They become an interference pattern. They become interference pattern. And we have already mentioned about Huygens laws. But Huygens law is not very important. They never come in A-level before. So we just skip that. Okay, we just directly know that because here got many point sources, they will produce their wavelet and interfere to produce constructive and destructive interference. Okay, so this is actually the intensity profile. Why this is so high intensity? Because it's very bright in the middle. This one has no intensity at all. When we draw, how do we draw? Where's the angle? We always draw from here. And we call this angle theta. So we have this formula called sine theta equals to lambda over b. So this opening slit width is b lambda, the wavelength, okay? Now we also have another formula that is from here to here. The distance is d, and this is y. We can use tangent theta. We can use this triangle and get tangent theta as y over d. And what is y? And what is this y? Y plus y. This become the 2y. We call it the width of central bright band. So it's the width of central bright band. This is the one that they always ask you. For single slit, we got these two very popular formula. And you got to always remember this construction, okay?